feel free to turn your cameras. It's always good to see people's faces.
Brendan's napping. I can't, sorry.
I figured you were whispering.
Yeah. She'll wake up soon. Now maybe I will.
Okay. All right. I mean, we might as well get started, I think. People are still trickling in. Whatever. All right. So, hello, I'm Aaron Young. I'm a co-president for Wisconsin Autonomous. So, thank you for coming to our new member meeting. I hope it was relatively painless to find the link and everything. But hopefully we'll give you, or the purpose of this meeting really is to, looks like another person's trying to get in, to give you an overview of our organization and some of the projects we have available, as well as give you kind of a backstory and, kind of include everything about this team just to give you, the best interpretation of what we're doing and what our upcoming goals will be. So I guess we'll get started, and feel free to stop us at any time if you have any questions. We'll try to answer them as quickly as we can. And then also, or if you want to, you can put your questions in the chat and we'll get to those. But at the end, if we have time, we'll jump into different sub teams. So maybe you can jump into a team that maybe you find interesting. So yeah, we'll get started. So this is kind of the structure we'll go through. We'll touch on each one of these. And at the very end, there'll be a few QR codes we'll have you scan. I think there's some links below it, but if you can, have your phone ready to scan those QR codes, because there'll be some like forms and jumping on our Slack channel, things like that. So just some logistical updates. So guys, as you guys know, we are kind of, or not, you guys won't know this, but we're kind of a hardware team as well. But as you guys know, COVID has thrown us all into a loop. So we won't have shop access for a little bit. This is kind of not necessary for you guys at the moment. But the second bullet point is, so we use Microsoft Teams for all of our video conferencing, which is the platform you guys are using right now. So in the future, at the end, we'll have you join our Microsoft Teams channel, or Microsoft Teams team, and join some channels based on your sub teams, where we'll have our sub team meetings, and we'll touch on all of those later. And I'm not sure about anybody in this meeting right now, but there's a reason I'm recording this, and it's because a few people have reached out from areas not in the United States, which means that their time zones are a little different than ours. So this meeting I'll be recording, and then any future ones that we deem necessary, we probably will. And we'll be kind of having this smaller group with students that are not in the United States. So if that's you, please let us know, and we can make some accommodations. So next, we'll kind of give you an overview of autonomy as a whole, and then where we fit into that industry. So autonomy is really a super general topic. You have autonomy in transportation. I'll kind of define autonomy. Autonomy is basically having different processes do it by itself, either through technology, or actually basically through technology. So transportation, where we kind of focus on, creating safe.
You muted yourself.
Oh, geez. Sorry, I didn't know I did that. I didn't even do that. That's weird. How long was I muted?
Like 10 seconds.
Got it. All right. So in general, autonomy is what we're focused on. And as you can see, it's a growing industry. And our hopes is to prepare you for when you leave college or you gain internships or things like that, that you're prepared for different aspects of this kind of world, and you're prepared. So as you can see, especially in the autonomous vehicle industry, there's really a lot of companies involved in the production and development of these kind of products. So I mean, take a look. I'm sure you've heard of some, if not all of them, and they're all connected. For example, Waymo used to be a Google company, but now different companies are investing into them. And as you'll kind of meet, a few of our members have actually had internships at some pretty large companies. And Wisconsin Autonomous on that resume is a super important factor to gain those type of experiences. So Wisconsin Autonomous, we saw that landscape in about 2018, and some of the past members who were involved with a hybrid team decided to kind of transform that organization into an autonomous vehicle or an autonomous vehicle team because it's so important to get involved in the industry because it's so new. And our goals are really to make a research impact and have our members learn about autonomous vehicle development in general. So as you can see, we kind of have this startup mentality. We're currently competing in 2 competitions, the EV Grand Prix and the Indy Autonomous Challenge, which you'll see in the next 2 slides, or I think 3 slides. And within those competitions, there's different elements that we have to do. So different custom designed software packages, different actuation control schemes, remote stop systems, and it's really accessible for all majors, all students. So you can see in the top right, we have these charts from last year. So the majority of our team was underclassmen, freshman and sophomore. But as we're growing, we're hoping the freshman and sophomore kind of progress in the organization, and then we continue to gain these new members. So hopefully we'll grow, gain experience, and hopefully improve as an entire organization. So our current sponsors are not actually inclusive to this, just these sponsors. We're reaching out to new industry leaders, every month, talking with different ones every week, things like that. So our current competitions and our focus over the past probably 4 months or so was the EV Grand Prix and the Indy Autonomous Challenge. The EV Grand Prix was basically a kit vehicle competition. So you buy, as you can see in the bottom left image, a kit vehicle from like a go-kart racing circuit, and we retrofit it with, you'll learn about what actuators are, but essentially different motors to control the steering and the braking and throttle, remotely, which is pretty neat. And then we developed the software then to control the car. And then the Indy Autonomous Challenge is a new competition. It's pretty exciting. So it's at the Indianapolis Motor Speedway. And the goal of the competition is a head-to-head race at 180 miles an hour with Indy Lights vehicles. So Formula One has, full scale or vehicles that are a certain size. It's the next tier down is what we're developing our software for. And as you can see in the next image, so we had a competition that we went through this past week. It's called Hackathon, or it's called a Hackathon. Basically, they give us 2 scenarios that we have to complete in the simulation framework, and we essentially compete in that competition. And as you can see, there's a bunch of different universities that we competed against around the world. We're up here, and in this kind of animation, you can see our car driving through the virtual Indianapolis Motor Speedway. We completed our lap in around, I think, 78 seconds. And which is, in my opinion, pretty fast. The car was limited to around 200 kilometers per hour, just because of the simulation model. It's difficult to create a simulation model that allows the vehicle to go at such high speeds, but we're aiming for, by the end of October, to go up to around, I think, whatever 180 miles an hour is in kilometers, but 180 miles an hour. And the next slide, you'll see this is the EV Grand Prix. So this car was retrofitted with, like I was talking about earlier, kind of autonomous robotic elements to allow it to control itself. And this was from, I think, a year ago. This past April, the competition actually got postponed or canceled due to COVID. So this upcoming April, we're hoping to compete again. And this is kind of where the hardware team lies in the majority of their work. So I'll kind of touch on the structure of our team as well. And along with that, I'll tell you kind of how we run our organization, when meetings are, and then also a special thing that we do at the end of our all-team meetings called brown bags. So as you can see, there are a lot of opportunities for progression in our organization and gaining leadership positions. So in total, we have 10 sub-teams, or actually we kind of have, I would say we have 10 sub-teams and 10 positions to fill in a given year, along with 2 presidents. Currently, there's 4 openings, 2 in software and 2 in operations. So if you want to get involved and progress in the organization, there's definitely opportunities. And as I was saying before, members continuously graduate. So some leadership positions may open up, and for sure, compete for those positions because it looks awesome on a resume. I can assure you that. So how our organization is ran is basically different elements we use to kind of organize everything that we do. So Trello, if you all have heard of it, it's basically a management tool which has different so-called cards that describe different tasks, and we aim to kind of describe our entire next 2 weeks, next month, next semester with these cards, and then we aim to complete them throughout the semester. Slack, if you guys have heard of that, is a communication tool, and that's where we do most of our direct messages, day-to-day communication, things like that. Our Google Drive is for documentation. You guys have, I'm sure, have used it, and our code is held on GitHub, so we have a bunch of repositories. And if you're on the software team, ideally you'd learn how to use Git, and it's a really valuable tool to have in your future too. So we have roughly 2 meetings per week. So this is an abnormal meeting time for us, at least as a whole team. So every Monday from 6:30 to 7:30, we have our all-team meeting, and then as you can see, we'll touch on each sub-team later. But each team has a different meeting time, and then your aim would be to sit in on your sub-team's meeting along with the all-team meeting. Right now. So at the end of our all-team meetings, we have a special kind of 30-minute talk that we call brown bags, which are essentially a way to teach you about key concepts that you might not find in the classroom or are applicable to each sub-team, or even maybe a refined topic that would be interesting to everybody just to know about or learn about. So those are really interesting, and I really recommend you stop by or sit in on those because it's really helpful. You won't learn this information in the classroom. You can ask questions maybe that you're not comfortable asking in the classroom, and different aspects like that. Another really awesome thing that we do is something called study groups or reading groups. So basically we have different papers that are all over the internet really. But sometimes it's really difficult to jump in and learn about these papers without knowing the background or understanding the language or like the verbiage. So what we aim to do is sit down and help read through these documents and kind of summarize as a group. Maybe some person understands this paragraph, but some person understands this paragraph. So you help comprehend different academic papers, and in the long run, maybe produce some of our own. So it's a really awesome tool that we have. Alex leads this, which is our other co-president. If he wants to chime in, he can. But these are held currently. The meeting time is Mondays, 12 a.m. to probably 1, or not 12 a.m., 12 p.m. to 1 p.m. But that might be subject to change. Is anything to add there, Alex? I don't know if you're.
Nope, that looks good. And hi, everyone. I'm the other co-president of the team.
Okay, sweet. So we'll move on to some of the sub teams. And again, feel free to ask any questions. Let's see. So our sub team, I don't think he's here. Our sub team lead for vehicle systems is Zach. Should I take this or?
I can take this one.
Okay.
All right. So the sub team will be meeting Thursdays from 5 to 5:30, and as a reminder too, we'll be sending out the times for those, so that and like the way that you access them later. But yeah, go ahead. So vehicle systems covers most of all of the mechanical work on the car, and it's very hands-on. So generally, you'll probably be like doing machining stuff, most electrical work that we do, various parts or like mounting different components. Over the summer, the steering and braking actuators were mounted, and that was like a project that the vehicle systems team will probably be working on. So coming up, once we get shop access again, which will hopefully be soon, we'll be doing an autonomous drive. So there will be some electrical work to do before we can do that. And then we're also hoping to put together a CAD model of the vehicle, and that will help some other designs to make the cart person drivable and put the seat back in so that we can compare the cart driving autonomously to the cart driving with a human driver. And then lastly, we'll do some upgrades to the current electrical system and just put the cart through more testing in general. This is an example of one thing that you might be involved with in this team. This is a circuit design of using transistors and relays to turn on and off the actuators that we use. So this would be basically once the computer powers up, then we want to turn on, we want to control when we turn on the steering and braking units. And so that's what this circuit does for us.
All right, hey guys, I'm Jake Boyan, and I'm the leader of the actuation sub-team. So our weekly meetings are going to be Tuesday, 7:30 to 8, and we're going to start those next Tuesday, the 29th. All right, yeah, so in the actuation team, we pretty much deal with everything with the actuators. And when I say actuators, you can see the two on the right there. The one on the top is the power steering actuator, and the one on the bottom is the braking actuator. So what these do is they take the code and they actually turn it into movement, so we can turn the wheel or pump the brakes. So yeah, we deal with the CAN message protocol, so that's what talks to the actuators. And then we do CAD mount design for the actuators, so that's making mounts so they can actually sit on that cart that you saw earlier. And yeah, we deal with the performance testing of these actuators to make sure the mounts are working right and make sure the actuators are working right. So far we've gotten both actuators mounted this last summer. We've done a couple initial tests of the CAN messaging, which you guys will see in the next couple slides here. And then, so yeah, looking forward, we want to do more testing with how the actuators are currently mounted, just to get some more testing of our code. And then ideally, we're hoping to be able to, so how they're mounted right now, the seat for the cart is not able to be in there. So the cart's not like drivable by like a person and autonomous. We want it to be like that. So we're going to try to create mounts where we can keep the seat in there. So that's going to be a big project going forward. And then another project is to create CAD models of the actuators themselves for our simulation team. So yeah, looking forward, it's going to be a lot of CAD projects, a lot of SolidWorks, and hopefully we'll be able to get in the shop soon and do some testing. And then this is a video showing the power steering actuator working. So you can see it mounted there on the steering column. And then you'll see here shortly the wheels turning right there.
And then actually, if you go back a slide, at the same time, the motor was also being actuated in that one. So we've got the rear shaft back there spinning while we're controlling the tires. And so if you didn't see it, that was basically like controlling the brakes. And if you play it again, Aaron, if you look in the center of the screen, there's a little black like rubber covering, and that thing is where the shaft of the brake actuator is. So basically, play it one more time. You'll notice the yellow lines, those yellow, like the yellow hose basically is getting pressurized and jumping as the system gets pressured.
Anything else to add for hardware?
Nope, all good for me.
I think that's everything.
Awesome. So now we'll touch on our software sub-teams. So we currently have 5 software sub-teams, and each one of our sub-team leaders will touch on each. And yep, so we'll start out with perception.
Yeah, so I'm Mason. I'm the perception lead. I'm a junior in computer engineering, and the weekly meetings for perception will be on Thursday from 6:30 to 7. However, I'll send out a poll later to any new members interested on whether or not this time works, and if it doesn't for too many people, I'll certainly consider moving it to a different time. But for now, it's Thursday, 6:30 to 7. Starting this Thursday will be the first meeting. So then for perception, the purpose of perception is to recognize the car's surroundings, and that's determining what and where. So for an example, if there's a person standing 5 meters in front of the vehicle to the left, it's perception's job to figure out that person is there and where they are relative to the car. And another example would be like a stoplight ahead, whether it's like red or green or yellow even. And these are all kind of things that like we humans do when we're driving subconsciously. And so the goal of perception is to kind of translate that those behaviors that we take when we're driving to perform them with a computer instead. And kind of the overarching term for this would be computer vision, and that's exactly what the perception team deals with, basically teaching computers how to understand visual data. And one of the main ways we do that for autonomous cars is via machine learning. And there's tons of different subsets of machine learning in tons of different fields besides autonomous vehicles. However, for autonomous vehicles specifically, the type of machine learning that is most beneficial and most useful would be artificial neural networks. And all an artificial neural network is a computer algorithm that's designed to replicate the way the human brain processes information. And the specific type of neural network that we deal most often with is a convolutional neural network. And like these terms, you don't need to understand exactly what they are now, like what exactly convolution is. But basically a convolutional neural network is just a type of artificial neural network that's used for multi-dimensional data, such as images, where you've data that runs in two different axes, so like the X and Y axes. And so perception also deals with the sensors themselves that's used to perceive the environment. So like camera, LiDAR, and radar. And I'm sure everyone's already aware what camera is. But LiDAR is a type of sensor that basically sends out laser beams and then waits for those lasers to reflect back. And then using the speed of light, you can calculate how far that laser traveled before it was reflected. So basically what a LiDAR produces is a 3D representation of the environment with a bunch of small points that mark where the kind of objects that it reflected off of are. And the radar works the same way. I'm sure everyone's familiar with what radar is. The difference between LiDAR and radar is just that LiDAR uses infrared light, so laser, and radar uses radio waves. So down in the bottom right is kind of just the different sensors that are typically found on an autonomous vehicle. Yeah. So then the past progress we've made last semester was mainly getting the perception done for the EV Grand Prix go-kart. And that dealt with both the camera and LiDAR. And you can see in the top right, that's not our go-kart, but you can kind of see the setup. And those little QR code looking tags are just, they're called April tags. And that's basically what we're using to pick up on the camera to identify other vehicles that we're racing against. And then we also got a new cone detection model trained for our neural network. You can see that kind of down below. And the new one's much faster and more accurate than the old one was. You can see down in the bottom then also that our goal is to detect the cones and where those cones are positioned. So each cone is assigned a distance and an angle to the center of the camera. And then you can see those polar coordinates plotted then in the XY plane on the left. And that's basically the points that would be passed on to like the path planning portion of an autonomous vehicle to determine where the car should drive then. And so then the active projects for this semester will be building a custom neural network to perform this object detection. So right now we're just using an off-the-shelf one that exists already that we trained manually. However, the advantage to designing our own custom architecture would be that we can fine-tune the speed and performance to kind of maximize the potential. So that's a more in-depth project. Probably not one suited to new members, but certainly if it interests you, it's something that I could give you like an intro on. And then another task is going to be gathering LiDAR data to train a neural network to detect 3D objects. And so for that, we're going to be using simulation to simulate a LiDAR as well as an environment. And then we can record the data for that we can then train a neural network with. And then along with that, all that data has got to be categorized and sorted, preferably for certain situations. So for example, if we wanted to collect data specifically for a car driving at high speed, we could collect that And then at our fingertips, we'd have kind of data organized based on that scenario, driving at high speed, in case we ever wanted to test on that scenario in the future. You can go to the next one. All right, so here's a kind of preview of what the perception would look like for the camera. And here you can see, this is with our scale vehicle. So it's like a RC car chassis that we've converted to autonomous car. And if you restart it again when it finishes, you can see it detecting the cones. And then you might also be wondering how it's getting the distance for those cones. And for this, we're using a certain type of camera called a stereo camera, which there should be an image, but I don't think it shows up on there.
Yeah, it shows up in the very beginning.
Okay.
I don't know if you can see that.
All right. Yeah, down in the bottom right. That's what a stereo camera looks like. And all a stereo camera is two cameras positioned next to each other, slightly separated, kind of like your eyes are. And stereo cameras are able to calculate depth using something called the parallax effect. And this is actually the same phenomenon that your brain uses for perceiving depth. So that's how we're able to calculate the depth once we know where the cone is in the image. So that's pretty cool. So yeah. Then we also have LiDAR-based perception. And here you can see, this is what the output of a LiDAR looks like, where each of those little points on there is a laser beam that was reflected off of an object. And then the red and green dots are the positions of the barriers after they're detected. And so in one of the next few slides, I believe, somewhere else in the presentation anyways, you'll see like a visual representation of what exactly the LiDAR is seeing in here. It's basically just a racetrack where the red and green mark the boundaries. And obviously the boundaries are important to know, so we stay on the track at all times. But yeah. And there should also be, yeah, that one doesn't show up either, but there's a picture of the LiDAR in the bottom corner. And that's one of the LiDARs we have that kind of gives you an idea what it looks like. And that black housing is where the lasers are emitted from. So yeah.
Awesome. Thanks, Mason. Now we'll go to state estimation. Alex, you want to talk about this?
Yep, sure thing. So the state estimation team doesn't have an official sub-team leader yet. We're still looking for someone. So if you're interested, please join us at the weekly meeting. It'll be Thursdays from 5:30 to 6 p.m. And we'll talk more about the team and how we could potentially, how a leader could potentially be doing things with the team. So yeah, you can go next one. So the purpose of the state estimation team is to estimate the vehicle state and surrounding obstacles, meaning we're trying to find an accurate value for the vehicle's speed, its heading, its acceleration, and then also like the location of things that we want to avoid around us. This could be like people, it could be track boundaries, they could be signs, anything really that perception is detecting gets past the state estimation team and then mapped relative to the car. So the progress from last semester and over the summer was using some different models, one of them being a bicycle model, and combining it with something called a Kalman filter to more accurately estimate what those values are. In the picture to the right, there's plots for velocity, heading, and position, and essentially the Kalman filter is trying to filter out the noise from sensors and also use that model of the vehicle to come up with a better estimate. They also did some work mapping the obstacles, and so then this semester we'll be trying to incorporate that Kalman filter into the current vehicle control stack, setting up some other sensors, namely a wheel speed encoder and a GPS IMU so that we can measure our state better. And then we'll be testing those as we start testing the go-kart more. And then long term, it would be really cool to do state estimation with the LiDAR. But that might be a little bit ambitious for this semester. But this team in general involves a lot of statistics, a lot of vehicle modeling, and then kind of like a working knowledge of how perception and control will be using that data that will be being passed through the state estimation team. Yeah, so this is an example of plotting the boundaries as they're perceived from perception. In this case, the blue is the right side of the track and the red is the left, and then the line in the middle is how the car is moving. And then this would be an example of how maybe LiDAR data would be detecting those boundaries and how we want to plot them so we can plan the path for the car to follow. And this is an example of Kalman filtering. So in the upper left, you see the video of our little bicycle model as it's moving through space. It's doing a little figure-8 loop. And then these three plots in the top right is the position, bottom right is the heading, and then bottom left is the velocity. So if we just take a look at the velocity, say, we can see that it's moving around kind of up and down as the vehicle is moving. And then the model is predicting one thing in green, and some sensors are, if you just want to pause it right there, actually.
Yeah, that's what I was going to do.
Cool, thanks. Yeah, so the model is having some output in green, and then the like sensor measurements would have some noise in them and are jumping around a lot more. And so the Kalman filter is a way of combining those two sensor values and then coming up with a better estimate that more closely follows what the vehicle is actually doing. Yeah.
Anything else to add? Oh, sorry.
Nope. And again, the meeting will be Thursday from 5:30 to 6, and hope to see you there. No, yeah, I'll pass it off to Evan.
Sweet. Thanks.
Hi, everyone. My name's Evan Deutsch, and I'm the lead for the driving function sub-team. And the weekly meetings, I kind of messed it up when I originally put it in. This is right. We're going to be meeting on Tuesdays from 5:30 to 6:30, starting next Tuesday, not today, obviously. And if people can't make that time, I'll probably be like, if the new members can't make that time, I'll end up probably changing it. But for now, 5:30, 6:30 next week we'll be starting, and yeah, we can go to the next slide. So again, this says 5 to 6 on Tuesdays. So again, an example of me messing up the time of my meetings. There was some confusion, but it's going to be 5:30 to 6:30. To be updated on that, you're going to want to join our Slack. I think Aaron will probably provide information on how to join our Slack and be able to get more updated on our information. But essentially what driving functions is all about is we take in from perception some representation of the boundaries of the track, and then using that information, it's our job to tell the car how to drive. So there's a few different schools of thought and ways to go about doing this. I can just rattle off a few now just so you can kind of understand, if you join our sub team, what might be expected of you and what you might be working on. So given the boundaries of a track, one main thing that we work on is path planning. So if you have the boundaries of a track and you want to drive around the track as fast as possible, you're going to want to find a way to map out an optimal path around the track. Given we call it a global path because it's a path around the entire track, given if you're given that information. So it's a lot of stuff that we'll do, and a lot of stuff that probably newer members on our team will be doing is we'll provide you guys with like a representation of a track, given like probably 2 sets of points, one set for the right side of the track, one set for the left. And it'll be your job to, along with our help, and we've done this in the past, so we have tools at your disposal and people to ask questions for, but you'll be trying to use various types of algorithms. There are countless, pretty much. They range from like A*, which is like a very basic artificial intelligent searching algorithm, You can use an algorithm like that to find an optimal path around the track. You can use algorithms that find the shortest distance around the track. You can use algorithms to find the minimum curvature around the track. Something that a member of our team named Raj just did is he created a minimum time path, which essentially created a path around the track that minimized for the amount of time it would take the car to drive it, which is ideal. So a lot of different schools of thought, a lot of different ways to create global path planning algorithms. A good way to get started and something that is very important that we work on. Another pretty important thing that we work on to drive the car is path following algorithms. If you can visualize this, once you have a path for the car to drive or to follow and drive around the track, you're set like theoretically optimally. You're going to need a way to keep the car on the track and a way to tell the car how fast to go. And a path isn't going to drive the car by itself. So a path following algorithm will essentially take in the path that the car is supposed to follow, and it'll use perception data to figure out if it is on the path, maybe even state estimation data in the future to figure out if it's on the path, if it's not on the path, how far off the path it is, and if it is on the path, how quickly it can be going. And then given those inputs, we can output steering angles and acceleration values to tell the car how fast to go and how to stay on the path. Most specifically, a few different examples of path following algorithms are a PID. PID stands for proportional integral derivative, and it uses proportions, integrals, and derivatives to correct the error of the car if it's off the path and keep it as close to the path for as long as possible without the car straying away or trying to correct it too aggressively and maybe correcting it too much and then looping around the path. We'll have many meetings where I'll explain. If you're interested in joining this team and creating algorithms to drive the car, we'll have many explanations for these types of things in our private meetings. So I'll probably, if you have questions, you can save them, and I'll be very excited to explain anything about path following or path planning to new members. One more thing, another way that we can help drive the car is these approaches are pretty similar. The prediction under the in progress tab, if you see prediction horizon controller and MPC, those algorithms are pretty similar. What they do is essentially instead of planning a global path around the track and then following it, every single time step, it'll look in front. The car will take in the input of what the car sees, and then we'll come up with an optimal path in some way for like the next second or so, or the next couple yards or so, or whatever. And then every single time step, we update that path. So no matter what car drives in front of us, what obstacle is placed in front of our car, theoretically with these types of algorithms, we can always correct our path and drive out optimally around any track, even if it's changing. So those are all. A prediction horizon controller is already in the works. I can just swiftly transition into what we have in progress. Prediction horizon controller, it's on its way. It doesn't work as quickly as we would like it to, but we are working to optimize that and make kind of what I just explained, so it operates quickly, efficiently, and can update every time step. And what I said before with the global minimum time path that Raj is creating, we had that actually just about done now. It's almost finished, so that'll be really exciting. It'll be probably the highest efficiency for any path planning algorithm we have so far, so that's exciting. And then on top of that, we have we're going to begin working on MPC, which is basically just a more efficient version of the prediction horizon controller. And I'll probably be explaining more about that again in private meetings, but those are the kind of algorithms we have going on now. Our next steps aren't necessarily things that we're trying to progress to, but it's actually just a variety of other different types of algorithms that we want to work on, because there's just so much to do for our team. There's so many different algorithms that we can create. And any algorithm that we get working, even if it's not the most optimal algorithm that we have so far, is extremely beneficial for just increasing the size and just the value that we get from our control stack, which is essentially all the code that we have. So we have so many different types of algorithms to create. We need a new updated, probably path following algorithm, because we can have a more optimal algorithm. There's a few out there that I have in mind. We have to come up with optimal ways for the path planning and path following strategy to find ways to race against other cars and avoid obstacles, because right now our only real short-term plan for competitions that would require obstacle avoidance would be using the prediction horizon controller or developing an MPC algorithm. But ideally, we would be able to make it work with the global path planning, path following strategy as well. I hope you guys are following this, but if you have questions, I'm more than happy to answer them in different meeting times. And then we also want to implement the algorithms, and like you saw the RC car and Mason's perception presentation. So we'll probably be trying to test our algorithms on that, which is super exciting. And then down here, we want to robustify our code, but that's not that interesting. We just need to organize it a little better and make it more readable. And then and our RL algorithm stands for reinforcement learning, and that's probably pretty deep into the future. But if you don't know what reinforcement learning is, I can explain it another time, but it's not a short-term goal. It's more of a long-term goal. But basically the point is we have a lot of algorithms in the works and a lot of stuff to work on. So it's a pretty exciting time to join. And that's pretty much it for that. Then now we're just going to show a variety of different algorithms working in real time. So this is our simulation environment. We have a 3D version that looks a lot like smoother and a lot like, I guess, cooler, but this is just a simple matplotlib simulation that works just as well. And it's just kind of showing off our PID, proportionate integral derivative. It's a path follower, just like I said. This is basically just a center line, and the car is following the path using our PID. So that's pretty much all that is. You'll probably, if you're on my team, you'll be working a decent amount with either testing your path planning algorithms with the PID or improving upon our PID or anything in that realm. So you guys will become more familiar with what a PID is in the future if you're joining my team, and maybe in general, if not. So you can go to the next one, Aaron. This actually was created by one of our members named Henkel last year. It's a genetic algorithm. I did not have a huge part in creating it, so I'm not going to try to explain all the math behind it. But essentially what this genetic algorithm is doing is looping through the path, and it's mapping out a global path using relatively simple but actually pretty accurate and complicated artificially intelligent algorithm. So this is something that is probably like a level deeper than new members will start at, but I think you'd be surprised how quickly you guys can learn how to build something as cool and as accurate as this. So that's kind of just showing off one of our global path planners that works very well, and it's not just a center line. And then this next video, my screen's white, Aaron. I'm not sure if it's like that for everyone, but I can't see the video. All right, now I can. So now I can't.
Can you see now?
Yeah, I can see it now. So essentially, this is the Gale car we were talking about earlier. It's probably, I'm guessing, in this video, just running a very simple center line follower, and it works, which is super exciting. But this year, moving into this year and into probably next year too, we're going to want to be starting to run our more efficient algorithms using the RC car on a more regular basis, just so that we can get things working in real life, in real time. That's a big goal of mine. Moving into the next year or two, getting things to being able to not just test things in simulation, but be able to test it on this RC car and on the real car. So definitely a big goal of ours will be to test more of our algorithms, and hopefully some of your algorithms on the car this year. It might sound crazy, but it's definitely a realistic goal very realistic goal for you guys, whoever wants to be on the sub team, to be able to build an algorithm this semester that we at least partially, if not fully, use to drive this RC car. And if not the RC car, all your algorithms will be tested in simulation, which is pretty cool as well. So yeah, that's pretty much all that I have. And I think we're going to be breaking off later in the team. So if you have questions for me, just write them down and I'll be happy to answer them. And that's pretty much it.
Thanks, Evan. And one thing to add to, so Evan became the driving functions lead last winter. So at the beginning of second semester of last year, which he was a second semester freshman. There's definitely opportunities even for freshmen to gain leadership positions. And as you heard, I mean, Evan knows a lot now at this point, and I'm sure if he hadn't been involved in this organization, he wouldn't know a lot of the things he was talking about. So it's a really great opportunity, and I just wanted to add that. So we can move on to software platforms now.
Hold on, but I just want to add on to that really quickly. That's why Aaron just hit it right on the nail right there, because as I was going through it, I'm sure you guys heard me repeat multiple times, like how surprising it'll be what you guys can create. And all of that was because of what Aaron just said. I became the leader of this team when I was a second semester freshman, and going into this club, I didn't have expectations to be able to build anything that they were showing me in my new member meeting. I'm like, this is all over my head. There's no way I'm going to be able to be a part of building algorithms like this. And it kind of seemed far-fetched to me, but that's why I kept putting that emphasis on that you really can, because it's more doable than you'd expect. And the things that you can do in this club and learn in this club quickly are surprising. So it's pretty exciting. And I just wanted to further add that because it is important. I think it's one of the most important things for new members to hear about this club.
Yeah, I totally agree. Thanks, Evan. All right, software platforms.
Okay, my name is Ian Rue. I'm one of the sub-team leaders of software platforms with Theo Hornung. He couldn't make it tonight. So our weekly meetings are Fridays from 4 to 5 p.m. Central Time. And you can go to the next slide. But if that doesn't work for anyone, just reach out, let us know. We're happy to accommodate time zone differences, or if that just doesn't work with your schedule. So most of what we do is software infrastructure and just communications between the vehicle and the base station. We also work on some safety systems along with the hardware people to make sure that we can stop the vehicle in emergencies. So one of our past projects was a vehicle control base station. So that essentially just lets us control what mode the vehicle is in without having to be in a terminal SSH into the vehicle, which can get a bit annoying. And it also lets us stop the vehicle in an emergency. It helps us make sure we know the vehicle is safe to approach. So it's not just going to go shooting off by itself. We also, just this past summer, we're working on our communications. So we wanted to be able to do it over both Wi-Fi and dedicated radios so that we don't have to have a Wi-Fi network around us to be able to communicate with the vehicle. We're doing this using a Mavlink protocol that's really common for like quadcopter-based communications. But actually, one of our upcoming projects is to revamp that communication stack to DDS, which is a newer, well, not newer, it's a more sort of industrially used, more reliable communication protocol. So that's one of the upcoming projects we have to do over the next semester. Some of our other upcoming projects are to transition from ROS to ROS 2. The major selling point of ROS 2 is that it's a lot more scalable, has much better reliability in terms of knowing that your data is, when you send it, it's going to get there on time, and you're not going to be waiting seconds, which can be disastrous if you're going at 180 miles per hour. We're also going to be finishing assembling our team PC. So this is a new thing that just came together over the summer. It's going to let us let the perception team train the machine learning models with some nice big GPUs that are dedicated to it. It also allows us to centralize sort of a data repository for different data sets from simulations and from testing. We'll also be establishing better sort of development pipelines and automated testing to make sure that our code base can just stay maintainable in the future and it's not all just hacked together real quickly and then never came back to. You can go to the next slide. So this is just a broad overview of the software stack that we use. The details aren't really important right now, but from the left, we have the perception code. They take in raw LiDAR data, radar data, and camera data. They run their algorithms on it and figure out where obstacles are, where the road is. They pass that off to driving functions or to state estimation, which also takes in like GPS data and IMU data. to make sure we know where we are relative to everything else and our absolute position. State estimation passes off that data to driving functions, which, as Evan was talking about, does the path planning and path following, and they pass off their instructions to actuation, which actually controls the hardware interfaces with like the CAN buses and the motor controllers. Then this is just some screenshots of our base station GUI that we developed over the last semester and over the summer, just to give you an idea of some of the options we have that we're working with. It can get a bit complex in the different modes we have to go in. But one thing that on the upper left, you can see we actually have it set up so that once we have the vehicle fully assembled, we can actually drive the vehicle with like an Xbox controller to test out and collect data. So that's one interesting thing that we just got working. But yeah, so that essentially wraps it up for software platforms. If you're interested, make sure to join the Slack team or Slack channel. And our meetings will be starting this Friday from 4 to 5.
Sweet. Thank you, Ian. And also, I just wanted to take a 2-minute break right now. Riley, are you available to talk right now?
Yes, sir.
Yeah, so Riley has been a member of our team since last year. He was a sub-team lead for software platforms too, but I just wanted him to touch on kind of his experience on the team and how all of this may sound a little complicated, but it's not as complicated as it seems. So Riley's going to talk a little bit.
Yeah, so basically, like I've watched this presentation a couple times and I still don't know some of the stuff they're talking about, and I've been in the team for like, I don't know, 2 years almost. So like, especially for the new people, like I know there's a lot of big complex words and algorithms and things being thrown around, and a lot of the people, especially Aaron and Alex and some of them like higher up, they're pretty smart. So it may seem like everybody is like really, really like a lot smarter than you, and they're not. No offense to anybody else, but like everybody that is here right now all started in the same place that you guys are right now. And some of you might have a bunch of experience from personal projects or whatever, internships maybe, I don't know. And you might already know what they're talking about, and some of you might not. But just remember that everybody all started at the same place, which is nothing. And they all just, got interested in it, watched some videos, did some smaller projects to start off, and then progressed into bigger things. And so don't be intimidated to, throw yourself into it, even if you don't know what a PID controller is. There's so many resources available to go in and figure it out, both for yourself or, you have, I don't know how many people we have on the team now, probably 50 plus, maybe more, that are all willing and able to help, especially the new people, figure it out. So don't be scared to reach out, and don't be scared to try and throw yourself in as much as possible. Don't be timid and, kind of just like hiding in the shadows, waiting for somebody to try and make it all make sense. You kind of got to go digging for yourself, and we can help you if you need. So.
Yeah. Thanks, Riley. Yeah, I totally agree. If you knew everything that we were talking about, there'd be no purpose to this organization, because, it wouldn't be cool anymore. Everybody would know all the topics that we're talking about. So, I mean, that's the reason that we're here. We're here to learn. We're here to progress as students and as learners. So we're in this together. But yeah, Riley made an awesome point. So please don't feel worried or concerned about what you're seeing today, because we're all here to help. So, and then I'll talk about this. So this is our last software sub team. It's a new team this semester. We've kind of been worrying about it or working on it for the past year or so, but it's called Simulation. So we have our sub team meetings 1 to 1:30. This subject to change, and then also right now I will be the sub team lead because I have a lot of experience with it. But in the future, hopefully, we'll transition to a newer member, so that they can get experience with it, as I move on. So what is simulation? Simulation is essentially a way to test and visualize the real world, but on your computer or virtually. So it's an awesome framework to, Mason was talking about his perception algorithms. Those some of those images that you saw were actually trained and tested in simulation. Alex's videos that he showed about state estimation, those were in simulation. Evan touched on it. The videos that he showed were in simulation. So it's a really awesome framework, considering it's very tough, even at this point in the semester, to go outside and test our algorithms. So simulation is vital to our organization, and that's kind of why we're bringing this on, and hopefully we can generate something that is useful for beginners and deployable really on any computer, anywhere, anytime, and also looks and hopefully it'll look really cool. So these two pictures you see are from different simulation environments. One's produced by Microsoft, so you can see that everybody really works on simulation frameworks. So really our goals will be to generate our own simulation framework, either based off maybe an output from or a product from Microsoft, or from different open source engines that are available, as in public software packages that we can use. We want to be able to model the real world, but in simulation, so that our testing, once completed on our own computers, we can then bring it to reality, and it works out of the box. That's the hope. And then what we'll also be doing is generating tutorials, documentation, so that when a new member comes in, or someone's just going through the code, it's really easy to follow, really easy to set up their own simulation, really easy to test their own code. And that's really what we're hoping to set up. We have a simulation framework working. It's just this portion of it is non-existent. So we need to really work on this, and also possibly change our strategy and revamp the structure of our infrastructures, or the framework right now. So if you were to join our sub team, I kind of want to touch on what you will be doing, considering it's a new sub team. It's a little bit different than some of the other ones. So what we'll be doing is essentially researching state of the art, then basically taking what we find out and applying it. So finding a simulation engine that we can utilize, and then be able to use it for autonomous vehicles. If you have experience with C or C++, Python, that's really helpful. Have experience with different modeling tools such as Blender or Maya. No worries if you don't know what these mean. These are just different keywords. So if you do know what these mean, this might be the sub team for you. Unity or Unreal, different rendering engines. So if you have experience with these elements, this might be the sub team for you. So right now, our simulation framework is based off an open source. Open source basically means public to everybody, called Project Chrono. Developed actually at the University of Wisconsin-Madison and at the University of Parma in Italy. Basically has a bunch of different modules that you can use, like vehicles, sensors, Python, things like that. So you can see here is a use case. So on the right is real world, left simulation. Looks pretty transferable, really awesome. So we test it in simulation first, brought it to reality, and as you can see, it was transferred very well. So this is our hope, basically. And as I think it was, I don't remember who was talking about this, but this is basically our EV Grand Prix environment. So we talked about this earlier with our KIT go-kart. We're testing our algorithms here so that when we are actually ready to test it in reality, we're ready to go. So, and it looks pretty awesome, looks pretty realistic. We're hoping to bring this and improve this in the future. And then you saw this video earlier, but this again is a simulation framework that we've utilized for the Indy Autonomous Challenge. So we're basically trying to structure our environment like this. VR Experience is the name of the simulator, but it's very expensive. and it's not essentially doable for our purposes. So we're kind of maybe build off of this or learn from it and expand. So that was a quick overview, kind of, of our software subteams and our hardware subteams. And now this is our operations subteam. So Julia will talk about what this team is doing, I think.
Yeah,
Yep.
yeah, I'm here. So that was all a lot of technical stuff. But the fact is, when you go work for any engineering company, there's a lot going on behind the scenes you probably don't see, but you can get experience with the operations sub-team. So next slide. Okay, so if you're a business student, which if you're on this meeting, you're probably not, but if you are a business student, you can apply what you've learned in your classes. But either way, you can see the real life application of how business works in an engineering setting. So it'll challenge you to think in a different way. It'll also help you if you want to get an MBA in business or just anything you're interviewing for. Knowing those business processes behind the engineering technicalities is just a really, really cool feature of this club. Next. Okay, so the operations team, we're looking for 3 main people. So the first is marketing. So this is what you probably usually think of when you think of business. So social media, flyers or posters, the website, designing shirts, all that sort of stuff. Then there's operations, or I guess it should be called logistics. So that's like supply chain, how we get parts, where they come from, relationships with sponsors, running events, member acquisition, that kind of stuff. And then lastly, what I kind of specialize in is finance. So that's going through all of our numbers, looking at our budgeting, keeping up with those relationships with sponsors, and then at the end of the period, looking through what our spending has been like, develop a system for that, make some recommendations going forward. Next. So if you're looking to take on a little bit more or something different, this is definitely the sub-team for you. You'll probably have to manage a few different projects at a time, but pretty low time commitment. Yeah, I think that pretty much is a strong overview. Right, benefits. Okay, so of course, networking with the top companies, you'll get that. But then also, you'll have responsibility over own projects. So when you're interviewing and somebody asks you to speak to something on your resume, you can actually talk about how you led a project, which is pretty cool. Of course, I'll still be working with cutting edge technology. I see this more functioning this semester as like you are on a different sub team, but you're interested also in the business side and kind of dabble in it. So you get the best of both worlds. And then, of course, being able to see how business works in relation to engineering projects and technology. So yeah, we meet Mondays right before the general meetings. Just let me know if you're interested. And yeah, we can meet and talk about what it's going to look like this semester and what you'd be working on and all that good stuff. So yeah.
Sweet, thanks. So now we'll try to be quick. We're a little overboard on time, but this is kind of the next steps, the next immediate steps for all of you on this call right now to get involved and stay involved. So please pay attention here so that you can stay updated. So we have a Slack channel, as I was talking about before. If you can, QR this or take out your phone and scan this code and create a Wisconsin Autonomous Slack account. Otherwise, write down this link and go to it later. Also, we'll be sending out these slides to those of you that we have your email. So you also can come through here and click on this link. But join the sub teams that are applicable for you, including any other ones that you may find interesting. Feel free to just browse the channel list. So I'll be relatively quick. So sorry if you weren't able to get the QR code. We'll send this out. You can get the link. So we're using Microsoft Teams right now. Again, in order to get the links for these team meetings, you'll have to be on our team. So again, I don't think you'll be able to QR code all of these right now. But So this one will allow you to join our sub team or join our Microsoft team. I'll send out the link again, so no worries. And then you can access all of the sub team channels, the all team meetings, everything along those lines. So no worries if you didn't get it. And as you can see here, once you join the team, you'll be able to see the channel list on the left, along with different the meetings that are available in that sub team, along with the weekly schedule that we'll have set up once we have that figured out. In addition, as I talked about earlier, we have a brown bag seminar series that happen at the end of our all team meetings that basically outline different topics that are really important to either your daily lives or autonomous vehicles in general. Yesterday we talked about a proportional integral derivative controller, a PID, something that Evan touched on. Again, really complicated topic, but the goal is to learn about it, even though maybe you have no experience whatsoever. So this QR code will help us. It'll be a form that basically you fill out, tell us what you're interested in. Again, I'll send this out. No worries if you didn't get it. So many QR codes. So we have Trello. This is basically our project management tool. I'll send this out. Again, no worries. I'm going to keep going. This one is, so a lot of you have filled this out, have filled this form out before. So no need to fill this out if you already have. But this is the form that you signed either at eBash or the Student Org Fair. And it basically helps us send out emails if we need to. We won't be sending out emails after about the next week or 2 weeks or so. We'll be using mainly Slack, but this helps us grade interest in teams and basically all of that. So that was a lot of information. Any questions, concerns, please let us know. So right now, I think we're 12 minutes over. Hopefully, I was hoping that we were going to be a little early so that we could go into our sub teams. So I don't want to force you all to stick around. So what I'll do is I'll stay in this general meeting. We won't go to our sub teams on the channels. And if you guys have any questions, feel free to ask. But otherwise, I'll send out this presentation. You guys can get the links to everything on this slide. You can look through it again, find your interests, and then jump onto the Slack channel. Feel free to reach out to anybody that talked today, or even just like Slack in the general channel, ask questions. But otherwise, I think next step would be show up at sub-team meetings that sound interesting to you. Feel free to go as many as you want, and start programming an autonomous vehicle and start developing hardware for the vehicle. I don't know. Anybody have any comments, questions? I'll stick around here for a little bit.
I just wanted to say really quick, because nobody else mentioned it, we used to talk about this a lot, is like, you really, like, what you put in is what you get out kind of thing. So like I was talking about earlier, like diving in, like the more projects that you try and tackle and the more things you try and do, like that'll add up both for like your resume and just your general like experience as an engineer and stuff. So like, yeah, it really, really is beneficial to try and just jump in as much as you can and not be afraid to ask questions or try and take on projects, even if you don't know 100% that you can take it on by yourself, stuff like that. So yeah.
Yeah, for sure. So you guys, I think are all good to go, unless you want to stick around, maybe listen to someone else ask a question, or if you want to ask a question. But otherwise, we'll see you at sub-team meetings or on Slack or anywhere, really.
And the next all-team meeting will be next week, Monday at 6:30 p.m. So if you feel totally confused, just plan on coming next week, Monday at 6:30, and we'll help you get set up after that too.
Yeah, and just want to reiterate, I'm the driving functions lead, Evan Deutsch. If you have any questions about driving functions, look up my name on Slack, and I'm more than happy to connect with any of you. Don't be shy to reach out. I'm excited for people to reach out and to get more people involved. So Evan Deutsch, if you want to contact me, just Slack me, and I'm happy to answer any questions. But I'm going to be signing off. So, yeah.
Sounds good. Thanks, Evan.
I think the screen is still white for me.
Yeah, because I'm looking at Teams.
Oh, okay.
Sorry.
There might be one more slide after that too with the meeting times. There.
Okay,
so
wait. Sorry, 1 sec. I'm just gonna.
yeah,
Okay. There you go.
yeah. So if anyone is still unsure what those sub-team meetings times are, again, we'll be sending this out, but there they are. Again, all those meetings will be on Microsoft Teams.
Yep. No questions
Hello.
from anybody? Oh, sweet.
Yes. So I have a question about perception. Alex, I think you said that you were the team lead for that. What kind of stuff do you guys do? Like,
Well, actually, Mason is the team lead for perception. Mason, you're still here? You can go ahead.
Okay.
Yeah, I'm still here. I'm sorry, what was the question again?
So what kind of stuff do you guys do in perception?
So perception's mostly working with the sensors of the vehicle. So like camera, LiDAR, and we're kind of taking in the input from those the output from those sensors, and trying to recognize objects, both what type of object and where the object is. So kind of the stuff we deal with is writing algorithms that process images and or point clouds, which is what a LiDAR produces, to try and predict, like perform object detection, more or less.
And do you use like ROS to program like all your stuff, or is it just in regular?
Yeah, so ROS is the communication framework we use. So it's what we use to pull the data from the sensors and then pass it on to state estimation. But as far as the code goes that we work directly with, it's mostly Python. So we're writing code there, and that Python code interfaces with ROS to communicate back and forth between the different sections. And that's kind of the same thing with the rest of the sub-teams as well, is just communicating with each other through ROS.
Okay, so I have absolutely zero experience with ROS. Like I didn't know what it was until like a week ago. So I do have a little bit of experience with Python. How much do I need to know of both? I guess for like how much do you guys does perception use of both? Because I assume that most of the algorithms and the analysis and the code would be written in Python, but I don't really know how Python would interface with ROS.
Yeah, so I'd say for you specifically, or like new members specifically, should be aware, I guess, of what the interface looks like, and like I can help you get a better understanding of that in like the coming weeks. But it's not hugely important that you know exactly how to interface the two. The big thing is understanding the algorithms themselves and how to translate the computer vision algorithms into Python code, basically.
And I want to add something to that too. So sounds like you're a little worried about the learning curve and what you need to know to get involved. But I just want to say that, there's no prerequisite knowledge to get involved in Perception or any of the other sub teams. Mason, myself, everybody else on the sub team, or everybody else on the team came in zero knowledge. So Mason was talking about ROS, needing to know the interface. You can learn that, and Mason will help you learn that, learning how to use Python with ROS, how to use Python with training machine learned models. All of this is fairly simple to learn because, you have Mason to help you out with. So hopefully that's not something that you're worried about.
Okay, thanks.
Yeah. Any other questions? Oh, sorry.
Yep, everyone. I'm just a little confused about the whole how to join process. Is it an application, or do I just hop onto one of the sub teams, or that?
Yeah. So really, there is no application. What I would recommend is we have these. I'm trying to change the slide. So we have Slack and Teams mainly for communication, and really the getting involved. I would say progression would be join Slack, join our Teams channel, and then hop onto a sub team. You can hop onto as many sub teams as you want in the beginning, figure out what you like. But there really is no application. There's no need to let us know what you're going to do, because you can just jump on and figure out what is most interesting to you. Does that answer your question?
Yes, thank you.
Yeah.
Yeah, and then to add on to that, we use Slack as our primary communication, and so we don't email very much except to contact people who aren't on our team yet. But in the Slack channels, that's where we put all of our updates, announcements, any kind of information about meeting times, and just to talk with people in general. And especially in online in virtual setting, it's really important to get into that as soon as you can.
Any more questions, or feel free to ask. We're here to answer.
Hello. So I have another question about that. You guys mentioned that there would be a bi-weekly scientific research paper reading group or something.
Yeah. It's our study group, reading group. I don't know what it's exactly called, but.
So in that, do you guys just look at papers related to autonomy and cars and stuff?
Yeah. So we pick a paper, and then everyone kind of reads it on your own time, and then we talk for an hour and just discuss kind of our thoughts on the paper in general, and then what some takeaways could be, what questions we have, and then we talk about how we could maybe use the knowledge from that paper to apply it to our team and making different parts of it better.
And it's not necessary to read the paper beforehand, correct? Because you guys are.
Yeah.
It shouldn't be.
Yeah, I mean, if you want to just join and just join the conversation, you're more than welcome to do that. It'll be probably a better discussion if more people have read the paper, but you also don't need to read and understand every single word. Even just skimming it generally, get a general read the abstract, look through some of the pictures, read the conclusion, and then maybe just sort of skim through the general structure of it. That should be good enough to at least have a good a reasonable conversation about it. And yeah, by all means, feel free to drop into those even without having read it, just to join and hear the conversation.
That's pretty cool. Thanks.
Yeah. And yeah, that's a Slack channel. So make sure you join that one once you're on Slack, and then you'll be able to hear about more updates there too. And I'd also highlight the industry headlines channel. That's one that we just put links to different articles, different news and current event articles, and it's just kind of a thread of autonomous vehicle news.
Any more questions? Oh, hand raised. Yeah.
Sorry, that was an accident.
Okay. Thank. Thought we had a question. I mean, do you guys any more questions? Like last time, I'll ask, and then we'll sign off and follow up with an email, Slack announcement. But yeah, any last minute questions? Sounds good. Thanks for coming to the new member meeting. We'll for sure reach out with an email, but otherwise, hopefully we'll see you guys soon in a sub-team meeting or something like that. Thanks for coming.
Thank you for having me, Aaron.
Yes, Riley.
Yes, thank you, Aaron.
Bye.
All right, see ya.